Today's video is about computational thinking. So computational thinking is a way of problem solving. To be successful with computational thinking, it's going to use a combination of logic and maths. And there's three methods of computational thinking that we're going to have a look at today, which is abstraction, decomposition, and algorithmic thinking. So the first fancy word we're looking at is something called abstraction. And as a definition, it's removing unnecessary parts of a problem so that you can just focus on the main problem. Now that's a really common question that comes up on your paper 2 exam as a definition. It's usually a 1-mark question and this is the answer. So to actually use abstraction, you need to work out what is relevant in the problem and then what's not relevant. So you get rid of anything that's not relevant and then you can just focus on the main problem. Now this is especially important when you're thinking about programming. Sometimes people have great ideas and they'll spend a long time with their programming trying to do it. If that's not actually solving the initial problem you set out to do, then there's just no point in doing it. So you just need to be able to focus on the main problem, not get distracted, and remove anything else that's not necessary. Another really common exam question is they'll give you a scenario and you have to use abstraction to say what's relevant in that scenario and what's not relevant. If we just stick to the same rules that we've already talked about, then you just need to think about what the scenario is, think about what it's already told you that is going to be relevant in solving that problem, and then anything that's not, you can just say you've got rid of that. You don't need to focus on that anymore. The next part of our computational thinking is called decomposition. Most people seem to remember this definition because it reminds them of a dead body. And if you think a dead body is going to decompose, it's kind of the same thing where it's going to break down into smaller pieces. And it's the exact same thing with our problem solving. If you started with a large problem at the top, you might want to break that down into smaller problems so that it's easier to deal with. As general benefits of decomposition, if you're going to distribute these small problems to other people, it's going to get solved faster. And also generally smaller problems are solved faster on their own. And they will all feed into solving the overall main problem. So if you combine this with abstraction, you've already picked out what's important and removed anything that's unnecessary. And now that you've got that, you can break that down into smaller problems and then distribute that to a team of people who can work on it. The final piece of our computational thinking is called algorithmic thinking. As a definition, an algorithm is a set of instructions that you can follow to solve a problem. Quite a lot of time in lessons, teachers use the analogy of making a cup of tea, and then they'll talk about having those problems in the correct order to successfully make your cup of tea. For your exam, there are different methods of algorithmic thinking where you can show logically the steps of your problem solving. We're going to have a look at these in the next video, but the methods are going to be flowcharts, pseudocode, high-level programming, and exam reference language. Okay, so we've got a practice question for this topic. So a library has a computer system to record details of the books it has. Each book has the author, edition, book title, year published, and how many times it has been borrowed. Each book is given a rating based on author and how many times it is borrowed. This is quite a lengthy scenario, but this is the kind of thing I'm talking about that's been common in previous exams that you might get, and you have to use abstraction on this scenario. So I know there's a lot of information to take in here, but you might want to pause, you might want to have a look and maybe think about what's going to be relevant for these answers. So question 1, define the term abstraction, just a simple definition. And then question 2, give one example of how abstraction is being used in the design of the rating system. Okay, let's look at the answers then. So question 1 was define the term abstraction. So it's focusing on the main parts of the problem, removing unnecessary detail. And question 2, give one example about how abstraction is being used in the design of the rating system. So they're focused on the author and the title and how many times it's been borrowed. You can ignore the year it's been published and the edition. It's told you that in the scenario what the rating is based on. And that's it for this video. I'll see you next time.